Hi everyone. So today our plan is to talk about Docker containers on Azure. This will be our last assignment. We'll do this a little bit differently. I will take you through the portal, show you what goes into creating a container, but that is not how you're going to do it for the assignment. And I'm not going to take you through step by step how that works. That's part of the assignment, is to go read the tutorial that I posted on the website. And figure out how to do that. But I'll show you a fair amount about what goes on in the show. So with that, let's hop over and get into the portal. So this is the home screen for the portal. I'm going to go straight to create a resource. Then over on the left, I'm going to collect containers. And just again, a note about nomenclature here. You've worked with containers in the sense of storage containers. These are Docker containers, so yeah, Microsoft's got a problem here. So we wanted to look for the container area. There's a bunch of stuff here. The top three are how you'd use Azure in progressively more intensive ways for container deployment. We're going to work exclusively with container instances. We're creating a single container instance. You can create basically a private version of Docker Hub, a container registry that lets you store, company-specific, project-specific container images, Docker container images, in a registry that is very much controlled in terms of who can get into it, who can push to it, and those sorts of things. And then we talked a little bit about Kubernetes. That is also built into Azure, and that's obviously the orchestration of actually bringing up groups of containers that implement applications. And this semester is too short for us to get into that. So in this case, we're going to go and create a container instance. So some of this stuff will look familiar. You look at you have to select the resource group, and I'm going to grab mine, and you've done that before, so you know that. You want to give your container a name, so you can find it. I'm going to call mine. I usually use my initials so I can figure out what I'm dealing with. And I'm going to create a container that has the Nginx web server in it, so I'm going to put that in the name. We'll leave the region at Central US, which is our default for our subscription. So Azure helpfully provides some what they call quick start images, like 3 of them. You'll see in a second. They are used mostly for the tutorials, but they're kind of useful to just kind of play around with and get started. You can see there's the option to create an Azure container registry. When I click that, I'm going to get an error because I haven't actually set one up. And to do that, I have to create an admin user. I mean, I have to basically create the whole infrastructure that goes with that. So I'm not going to do that. And then you go to Docker Hub, and you can pull a public image from Docker Hub. I may make another video specifically on how to do that and what that looks like. I won't do it in this one, so it doesn't get too terribly long. We're going to go with this quick start images. There's a Hello World one, which is we talked a little bit about Node.js as a web, which lets you run JavaScript as a web server. That's what this is. It's kind of simple. It starts with a little image and a hello. We're going to go with the Nginx actual web server image, and look over here. The last thing on this main screen is you can decide how many resources the Docker layer is supposed to give this container. And it's measured, at least Azure, this is how Azure does it, measures it very much like you would set up a VM. Right? So I can ask to change it, and over on the right-hand side here, you can see I can give it up to 4 CPU cores. So if I have like a web server and I want to use multiple cores to serve a larger number of threads, I can do that. And I can also allocate more memory to the Docker container. So in some sense, of course, Docker containers act still like very lightweight virtual machines. So we're going to leave it at the default that comes up here. The next tab over is networking. You can either use the button down here or switch to the networking tab. So if I create the container, I can decide that I don't want it networked at all, which is kind of weird. I can give it a private address if it's a container that I'm only going to use inside my Azure cloud that isn't accessible from the public. We're going to make ours public, and we're going to give it a name. So this is going to be HK Web. By the way, the name has to, of course, be unique within how it constructs the domain name. So if you type something too simple, it'll probably kick it back saying it's already that's already in use. So there's my DNS name. And by default, and this is kind of interesting. By default, containers on Azure are designed to pass through port 80, and you can add additional ports. We're going to not need that. All we want to do is have a simple web server come up on port 80. Here's the Advanced tab, and I'm going to spend a little bit of time on here because we'll take a little bit of a look at this when we get to the Azure shell. So these are some settings that you may want to pay some attention to, not for our assignment, but overall. So like anything else, the system, the operating system container or your application can crash, but it's a container. What do you want to do, right? So the default policy is that if something fails, the thing crashes, it's supposed to try to start itself back up, and you can set this to always or never as well. So you could say anytime the container goes down, for whatever reason, bring it right back up, or if the container goes down, I don't want it to restart. I want it to go away. This is a Linux-based container. Linux and Windows, of course, both have this concept of system-wide environment variables, or not system-wide, login-wide environment variables. So these are things that you can. So these are things that might be useful, like in a script, to be able to pick up, and you can set them here. So these are not hard. Remember. Take a step back here a second. Remember that a container image has been built from a Docker file. So when you create the Docker file, we talked about a little bit. You specify a base image. You specify various commands to create the environment that the container starts up in. In this case, and that would include setting any environment variables that are sort of constant. But in this case, if I create a container, I want to customize it. I want it to do something a little bit different from the sort of the generic container. I can set environment variables here, and then that would change the behavior of the container. The same thing's true here. So I can have a first run command. So my container might contain a script that, I don't know, reaches out to a cloud storage and pulls in data that the container needs to have, that needs to be up to date, that I want to store in the registry. So I can do that here, and that's pretty cool to be able to set up. And there are a couple other things you can do similar to this, but there are some that are only available with shell. But these are the container, because unlike a VM, you don't log into it with SSH. Although again, I'll show you a little bit. We can poke at it a little bit. You don't log into the SSH and finish the setup. So and how do you actually customize a container to do exactly what you want it to do from the base of the container image? And this is part of your ability to do that. And then there's this is for bookkeeping again. I can create tags, which just like with the VMs, it lets me do accounting. So who within my organization actually gets billed for the use of these containers. So when I get to that point, I can tell Azure that I want to review, so it'll check and make sure that everything is still good. Nobody's picked up, like the domain name, for example, that I asked for. This is an Nginx image. You can check that it's in the right subscription, the right resource group. Yeah. And then I am going to now create the container here, just because I already have it set up. This is not what you're going to do. Feel free to poke at the screen. You can even create a container, but for your assignment, you'll have to show the actual shell commands to create a container. And the good news is that most of these things are defaults, so you won't have to type it like a super long command string, but you're gonna have to kind of play around with how that works. So I'm gonna go ahead and create this, and as always, it's gonna take a little bit of time. Okay, so we're back. I waited for I think about 4 minutes, something like that, for the container to come up. So let's go take a look. Here's the container. We're going to grab the domain name, and we'll grab ourselves a little bit of the browser window, and there is our Welcome to Nginx default page, right? So that's our container running a web browser. And we probably can't see it in here, but there's there it is. There's kind of a little bit of a spike in memory usage when we actually made that request. I mean, obviously we're not doing anything that loads this guy at all. All right, so now we're going to hop over to the shell, and what I did here is I kind of like the split screen, so I can click over here and grab a Cloud Shell. What I did instead is I went directly to a different URL, shell.azure.com, and that gives me an entire browser window with the Azure shell. Super helpful. I think if we're going to be working with, looking at working in a shell, I prefer. I can't do it because of the recording software. Normally, I probably would have the portal in a smaller window, and I'd sort of partially overlap with my command window, but the recording software wants to grab a window, so I'm working with tabs here. All right, this is how you're going to work with Azure containers. Although you're obviously welcome to pour on the portal and look at the properties like we just did in the other screen. So the AZ container command set is what you want to do for this. So like anything else in most Linux environments, you can get a lot of direct online help fairly quickly without even going to the tutorials, although they're clearly there for that purpose, right? So what I can do, if I can spell, I can use --help or -h. I think works as well. So the AZ container command set is what we're going to use. The one that you'll need is right here. You want to create you're going to create a container group. A note here on the nomenclature. Normally, applications require more than one container, right? So you'd have like something that runs the web server and something else that runs the PHP code, or something that runs the web server and something that runs the database engine, which in turn goes back to a backend database that is permanent. So normally these things are deployed in groups, and so what we're doing here is deploying in groups of one. You can delete them, of course. I get back to exec. This is how you actually get into. This is how you take send a command into a running container. So in the initialization screen, we saw an option to have the container run a command when it starts. But even if the container is running, I can still issue commands that get executed inside the container. We're going to look at the list option here in just a second. You can examine logs from the container. You can restart them. You can get details about the container. You can start. If you have a defined group of containers and container images, you can start that. It's somewhat similar to the creating a container group, and then of course I can stop containers as well. All right. So what you're going to do is do a command to create a container or container group, and so we can do -h or -help here as well. Obviously, there are a lot more options, and you'll have to kind of work through this, not through this in detail. You have to figure all of this out. What you want is to go through the tutorial that I linked. You have to work through that, figure out what it is you're supposed to do, confirm it against this, because this is the kind of the definitive command reference, and then go from there. There's really only a few things in here that you would have to set up, like the DNS name label. If you want to run a command for the first time in a container, when the container starts, you would put that into the --s command line option. To open more ports, you would do that with the ports option. There's the restart policy we looked at. When does a container start or not start? Here are environment variables, and secure environment variables. There's some other ways of getting things like passwords or SSH keys into a container. You can attach file volumes. There's some other more advanced options we're not going to go over here. Not all, some of which I don't really know what they do. And you can network. You can set up how your containers are networked. There's global commands, and there's a bunch of examples. Cool. So you'll have to figure out kind of a minimal set of options to put with your container create command to actually create the container in your command shell. All right. Now, once the container exists, obviously I want to see what containers I'm running. Normally I have quite a few. I should only have one. So let's test that. So I'm going to do a container list. And I got output that is both complete and not terribly usable. All right, so this is actually a JSON file. It's meant to be used in scripts where you run a script, you run that command, you pipe the output to something that can read and parse JSON. Great. Generally, we don't do that. Although, the advantage here is that you can absolutely find everything you want, right? You can find the DNS name, all that good stuff. Generally, if you want to check that your container is actually up and running, what you really want to do is container list and specify the output option as table. Now, would help if I did this correctly. There we go. Notice, by the way, that I didn't retype the command. Up arrow brings the old command back, and then I left arrow to correct what I screwed up. So this gives a tabular output. So if you have 5 or 6 or 10 of these things running, you get a much better tabular output. Notice that the domain name in here isn't actually part of this. There are ways to get to that. It's a little convoluted. Generally, you would use a list command, and the show command is meant to have access to more stuff, and it's easier to restrict it to just a resource group. Generally, you would do this tabular output just because you want to get a quick overview and see if stuff is running. But there are ways to query an individual virtual machine, not virtual machine, an individual container, and get more information. All right, so the one thing I want to show you, because it's kind of cool, and hopefully I don't screw this up too badly. Right, so I'm going to actually the attach command would take any output that programs within the container generate that would normally sort of go away into sort of non-existent console and pipes it here. So if you wanted to see like the log from the web browser, from the web server as we browse to it, you could do that with the attach command. And I think is there a detach? I can't remember now. I don't know. Oh, that's right, there it is. So I could do something like this. So this container is called HK Nginx. So I could do an AZ container. I want it attached to its console output. I need to specify a resource group. So the tab completion works if you remember to type 2 dashes at the beginning. So my resource group is HK test. I need to specify the name of the container, which is HK Nginx. And I think that's all I need. Let's find out. Yep. And so now I'm seeing, and I think there's something monitoring this this container, which makes sense. But you can sort of see what the what's coming out on the logs, and Control C will get us out of that. All right. So the other thing I want to show you real quick, and it's going to be a little bit messy. I apologize in advance. But what I'm going to do here is I'm going to do the same thing with request a container. This time I'm going to tell it I want it to execute. I want the container to execute a command that I'm going to send to it. So I need to again specify my resource group. I need to specify the name. Okay. And I need to specify the command I wanted to execute. In this case, I'm going to tell it I want it to run the bash shell. Now I have a bash prompt for the server that is running our Nginx web server, which is kind of cool. I mean, this is really useful mostly for troubleshooting. You really never want to do this as an operational thing, but the fact that you can do this is kind of cool. And most of the time, the exec is used, like I said, to run a script inside the container to either produce logs or change its behavior in some form. In this case, what we're going to do, and so this is where it gets messy. The output will wrap in a really bizarre way. So what I'm going to do here is, before I type a command, I'm going to grab a new line so you can see what I'm typing. So I'm going to go to the user share Nginx HTML directory. That and notice that it kind of messes up. It kind of messes up the wrapping. So what I'm going to do now is list the files in this directory. Index.html is what we just looked at. Let me show you that. So I'm going to type out index.html, and there's the welcome to Nginx, and you see this page and so on and so forth, and of course that's what we saw right there. Okay, so just to show that we can actually change the behavior change the behavior of our web server. Notice that there's a second file here, 50x.html, which is an error page. I'm going to force the server to always serve up the error page. So what I'm going to do here is I'm going to copy the 50x file over the index file. So if that succeeded, that should have changed the behavior of our server. So I'm going to reload our page, and now it's serving up a different page. Let's see what we actually sent it now. All right, so this is now, we said change the file. This is now the error file. Okay, so what did we just do here? We created a container that contains a web server serving up a simple static file, and obviously for a real container, I would have set the container image up to contain sort of the static portions of my website. deployed the container, gave it a publicly accessible IP address and domain name. And normally, what you would obviously do, this is not a domain name that makes any sense, but you could, in DNS, we could very easily obviously create a CNAME and point to that from a more user-friendly name that maybe in our company's domain. So that's running, the server's running. I can get information about the running, the running container. I can send commands into it, and in fact, I can send a command into it. It gives me an interactive shell, and I can do at least some troubleshooting diagnosis of what's going on inside the server. Okay, and we can sort of see. We look here. I mean, again, nothing much is happening. We're not really putting any load on this container. All right. So that's what I wanted to get to here today. So I've shown you how to find containers in the portal. I've shown you how to find the Azure command set, container command set in the shell. So you have all the basic information. The assignment is going to be very simple. Do something like this. Right? So you're going to have to, but you're doing the command line. So you're going to read the tutorial, the section of the tutorial that talks about how to deploy a container in the CLI, in the bash CLI, not PowerShell, unless you absolutely want to do that. You know, figure out the commands. You have to try them out. Stuff may go wrong. Fix it. You can always delete containers. Something that's totally right. It shouldn't. Either you create the container, or you don't. Right. So if something goes wrong, you get an error. Figure out what you did wrong. Usually, it tells you pretty clearly what it was missing. Right. So you create the container, and then you'll do the same thing. Attach with bash, and mess with the index file, and then you'll leave the container running just like you left your VMs running, and I'll kind of go through when I get around to grading. I'll kind of kill all that stuff off. That's going to be your assignment, and then I'm going to be working on another video, another couple ones probably, leading into the final project. Give me about another day or two for the final project to come online. It won't be very voluminous, but you'll have to do some research and then test out a few things in Azure to do that. All right. So questions? Hit me up on email. Twitter, of course, would work. Those of you that are on the Discord server, I think hopefully found out that you ping me on Discord. I'll reply really quickly because that kind of pings as I'm, where I'm sitting and I've got it on my phone and what have you. So if you run into trouble, just reach out. The one thing I really, really don't want you to do, just like the last time, don't wait until like an hour or two before this thing is due, and I'll make it due next weekend again like I did before. Don't wait until the last minute, because then if I'm not around, or if it's something that I need to do a little research on, figure out what we ran into, you might be in trouble. So get started on it as soon as you can. All right. Any questions, reach out. But hopefully this at least gave you some idea the environment you're working in and what you're going to get yourself into.